Lesson 3. Using Sound Waves. Reading Guide. Key Concepts. Essential Questions. In what ways does sound interact with matter? How can people control sound? What are some ways to use ultrasound? Vocabulary. Absorption. Reflection. Echo. Reverberation. Acoustics. Echolocation. Sonar. Inquiry. Where is it? These workers are preparing to lower a special device into the water that uses sound waves to search for underwater objects. Sometimes they locate sunken ships, such as the oil tanker in the large image. What properties of sound waves are useful for finding things underwater? Sound waves and matter. Why do the cheers of a crowd in an indoor gymnasium sound so different from a crowd yelling at an outdoor football game? Sound waves at the football game spread out with few barriers. What happens to sound waves when they strike a different medium, such as the walls of a building? Transmission. Have you ever heard someone talking in the next room? This is possible because of transmission, the movement of sound waves through a medium. When sound waves move from air into a wall, the vibrations of air particles cause particles in the solid wall to vibrate. Even though solids transmit sound waves better than gases, most sound waves do not move easily from gases into a solid. However, loud sounds, which have a lot of energy, will move into and through the solid wall. Waves of quieter sounds with less energy may be partially or completely blocked. These waves don't carry enough energy to cause much vibration in the wall. As the vibrations reach the next room, they transfer the remaining energy to the air particles and you hear the sound. The amplitude of the sound is lower because the wall could not transmit all of the energy. Absorption. If you throw a tennis ball at a pillow, it will not bounce back. Most of the ball's energy goes into the pillow. Some materials, such as the wall insulation in Figure 17, act like the pillow when sound waves strike them. The transfer of energy by a wave to the medium through which it travels is called absorption. How well a material absorbs the energy of a sound wave depends on various factors, such as its inner structure and the amount of air in it. Rather than passing from one particle to another, some of the sound energy changes to heat due to friction. Reflection. What happens if you throw a tennis ball at a hard surface? The ball probably bounces back at you. Similarly, a sound wave might bounce back when it strikes a different medium. The bouncing of a wave off a surface is called reflection. The way in which sound waves reflect is shown in Figure 18. The angle at which a sound wave strikes a surface is always equal to the angle at which the sound wave is reflected off of the surface. Key concept check. What are some ways in which sound waves interact with matter? Echoes. Have you ever yelled a name in a gym and heard the same voice yell back? That was you, of course. As you yelled, you heard the original sound of your own voice. Then you heard the sound again after the sound waves reflected off the walls of the gymnasium and traveled back to your ears. A reflected sound wave is an echo. Sound waves travel at about 343 meters per second in air, or 34.3 meters in 0.1 seconds. And the brain holds onto a sound for about 0.1 second. When the reflecting surface is far enough away that the sound waves take more than 0.1 seconds to return, the listener hears the original sound followed by the reflected sound. So, if you clap your hands at one end of a long room, you hear an echo only if the sound wave returns more than 0.1 seconds later. Reverberation. In many closed spaces, Sound waves reflect from surfaces that are different distances from the listener. Because some waves travel farther than other waves, reflected waves reach the listener at different times. The collection of reflected sounds from the surfaces in a closed space is called reverberation. Sound waves that reach the listener directly are heard sooner than reflected sound waves. If each reflected wave reaches the ear before the previous sound fades, the original sound seems to last longer. However, too much reverberation can make words hard to understand because the echoes of old sounds can interfere with new ones. Acoustics. In a room with no furniture, rugs, or drapes, the sound waves of footsteps and speech bounce around the room and sound loud. Soft or fuzzy materials, such as the rug, curtains, and padded furniture on the right of figure 19, absorb much of the energy of sound waves. Footsteps are almost silent. Voices are softer. The study of how sound interacts with structures is called acoustics. Acoustical engineers use their knowledge of sound transmission, absorption, and reflection to control sounds. Noise pollution and control. One way acoustical engineers control sound is by developing methods to protect people from noise pollution. Think about the noises people might hear during a typical day. Trucks rumble by, cars honk their horns, and claps of thunder boom during a storm. At home, you might use noisy appliances such as a hairdryer, a vacuum cleaner, or a dishwasher. Severe noise pollution can result in hearing loss, stress, and other types of health problems. Laws limit the noise that might be produced by machinery or landing aircraft. The government requires ear protection for workers in many jobs. Noise-canceling earphones, such as those worn by the person in figure 20, work in several ways. They cover the ears and can block incoming sound waves. Other types of earphones reduce the sound by analyzing incoming sound waves and then producing waves that create destructive interference. Designing spaces. Acoustical engineers develop ways to control sound in buildings. When you enter a concert hall, such as the one in figure 21, you might think that the unusual appearance is just for looks. However, engineers have carefully chosen shapes and materials to control sound waves. The stage has a wooden floor to improve vibrations. The curved panels on the ceiling reflect sound waves in different directions to fill the space. However, the recording studio has foam panels on the walls. These soft materials absorb sound waves to prevent reverberation as the musician performs. Key concept check. What are some ways in which people can control sound? Ultrasound. You have read that the waves of ultrasound have a higher frequency than humans can hear. Both animals and humans use these high-frequency sound waves. Echolocation. Recall that many animals, such as bats and whales, can hear sounds above the range of human hearing. Animals use some of these ultrasound frequencies to communicate. They use other frequencies to locate and identify objects. The process an animal uses to locate an object by means of reflected sounds is echolocation. The dolphins in figure 22 might use an echo to determine an object's distance, shape, and speed, or to find other dolphins. Sonar. If you go fishing often, you probably wish you could easily discover exactly where the fish are located. A device called a fish finder does just that by using a technology similar to echolocation. A fish finder is an example of sonar, a system that uses the reflection of sound waves to find underwater objects. The word sonar is an acronym for sound, navigation, and ranging. Ships use sonar to send a high-frequency sound wave into the water. As the sound wave moves deeper, it spreads out, forming a cone or beam. When the sound wave strikes something within this beam, it bounces back to the ship. Sonar contrasts signals that strike the ocean floor with signals from other objects. It measures the amount of time between when the sound wave leaves and when it bounces back. The sonar system then calculates the distance and draws an image on a screen. The picture of the sunken oil tanker on the first page of this lesson shows what a sonar image might look like. Reading check. How can people see underwater using sonar? Medical uses of ultrasound. Suppose a doctor could see your heart beating or watch blood flowing through your arteries. He or she could determine whether something was wrong without performing surgery. Believe it or not, as figure 23 shows, these things are possible using ultrasound. Ultrasound imaging. Ultrasound scanners work much like sonar. A doctor moves the scanner over different parts of the body. The scanner emits safe, high-frequency sound waves. Body structures such as muscle, fat, blood, and bone reflect sound at different rates. Based on the reflected waves, the scanner produces an image called a sonogram. It is even possible to analyze motion with ultrasound. The scanner in figure 23 uses the Doppler effect. By determining how much the frequency of the reflected wave changes, the scanner can determine the blood speed and direction. Doctors often use sonograms to check the health of unborn babies. Ultrasound is safer than X-rays because it doesn't damage cells. Treating medical problems. Has anyone ever massaged your neck or back when it was sore? It not only feels good, but it also relaxes stiff muscles. Many physical therapists use ultrasound to treat joint and muscle sprains or to ease muscle spasms. The vibrations travel through the skin and soft tissue and act like hundreds of tiny fingers massaging the area. Short pulses of high-frequency sound waves can even break apart kidney stones, as shown in figure 24. Key concept check. What are some ways in which people use ultrasound?